Welcome to Climate Now, a podcast that explores and explains the ideas, technologies, and the solutions that we'll need to address the global climate crisis and achieve a net zero future. I'm James Lawler, and if you like this episode, leave us a review wherever you listen to your podcasts, share the episode with your friends, or tell us what you think at contact@climatenow.com. We love to hear from our listeners. I do want to mention that this week, Climate Now is hosting a major summit on the future of agriculture in California. For those who are interested in attending, you can do so virtually for free by going to climatenow.com, navigating to Climate Now events at the top menu, upcoming events, and clicking on the Future of Agriculture Summit. If you happen to be in California, in the Fresno area, you can register to attend in person, and I think we still have a couple of spots left. In today's episode, we're speaking with Kurt House, who's the CEO and co-founder of KoBold Metals, a mining exploration company that is working to revolutionize how we find deposits of key minerals that are needed in the energy transition. But first, our news segment, This Week in Climate News. This week in Climate News, I'm joined by Julio Friedman, and we will kick things off with the latest IPCC report.
It's always a big deal when the IPCC issues a summary report, and this is no exception. They've pulled together the work from Working Group 1, Working Group 2, and Working Group 3 that were published last year and the year before, and pull it all together for everybody to understand and see. Interestingly, this year, they did something unusual for the IPCC, which is to focus on 2030 and what is actionable in the near term and immediately so. They did the regular work. I recommend everybody take a look at the summary report and the summary for policymakers. So far, they have estimated 1.1 degrees of Celsius warming. That's bad. So far, we are not on track to reach our climate goals of 1.5 degrees or 2 degrees. They've laid out a whole set of scenarios. That's bog standard work for the IPCC. They also show what will happen if we fail, what are the consequences. They've gotten better at that over the last couple of years.
So it's a deeply unsettling and challenging picture. What do you find to be the most compelling part of the report?
There's one image in particular that's gone viral showing people who are born at different generations and what the world might look like given those different impacts and scenarios. It's a really nice piece of work. It's a great image. I recommend everybody go take a look. For me, the most compelling thing is actually what they put forward on action plans and the opportunities to scale climate action specifically. Unsurprisingly, solar and wind are the big heavyweights. Between now and 2030, at low cost, they can each get about 2.5 gigatons of abatement. And if we're prepared to pay more, each of them can get more than ballpark 4.5 gigatons. So that's a lot. And it's not surprising because we've seen these tremendous drops in the price of solar and wind. They show the full list of everything in this report on energy supply. They talk about bioelectricity, including bioelectricity with carbon capture. They talk about geothermal and hydro and nuclear. They talk about fossil with carbon capture, but they also talk about land use changes. They talk about sustainable urban development. They talk about health services and consequences, how these investments might affect society. It's just a really good piece of work.
So in other news, the United Nations had its first water summit in over 45 years. Julio, tell us about that.
Secretary General Antonio Guterres really laid it out. 26% of the world's population, about 2 billion people, don't have access to safe drinking water. And in his comments, the UN chief said that climate action and sustainable water future are two sides of the same coin. People who study the hydrological cycle really understand that. So good to see this kind of attention paid to water and put forward in the context of climate action, especially the same week that they put out the summary report.
Great.
Other big news, the Biden administration is still working on its final methane policy with respect to regulations and so forth. But Michael Regan, the administrator for the EPA, came out today and said, in no uncertain terms, it's going to be stringent. He said there are no facilities that are getting out of jail free. They've got a very aggressive rulemaking process in place. So, again, on the back of the UN report, which shows that we need dramatic reductions in methane as well as dramatic reductions in carbon dioxide, it's good to see this kind of focus in government. Unclear how this will play out in terms of electoral politics or anything else, but nice to see the returned focus on the non-CO2 gases, starting with methane.
And what are the fines likely to be, or what are the fines currently for, methane leaks if they are assessed?
They are proposing very high fees, actually, as high potentially as $1,500 a ton, which would be quite a lot.
How is the EPA going to monitor and going to identify culprits in their crackdown?
Well, there's a lot of new tools that are out there. This includes airborne and satellite data. For example, the Environmental Defense Fund has been fielding its own space program around methane monitoring. There's really no room to hide anymore. And there are, in fact, a lot of tech companies that have come forward and want to offer this monitoring service. Some of that can be accepted proactively. Companies who want to show that they have low leakage can do so. They will do monitoring at the wellheads. They will do midstream monitoring. They will do monitoring at processing facilities. All of these are places where the EPA will get in and take a look. And because the technology has moved so far in the last 10 years and the accounting has gotten better, it'll be more straightforward to both prevent emissions, but also more straightforward to find emissions, and therefore more straightforward to penalize bad actors.
Very interesting. One other headline that caught our attention this week was United Airlines, which has set an aggressive target of completely erasing its greenhouse gas emissions from its operations without relying on traditional carbon offsets by 2050. They have formed a collaboration with Archer Aviation to use Archer's electric vehicle takeoff and landing aircraft to provide the first air taxi route in Chicago.
Yes, we finally have flying cars. We're all very excited about this. There's been a lot of work that's been done trying to understand the business models and pricing for air taxis of various kinds. We'll see how they go. But basically, the drone tech has gotten good enough to be car tech. And so, and it's basically electrical technology. So again, we're going to see something interesting happening there. United is definitely one of the global leaders on their own emissions footprint. They have an excellent chief scientist, and she has worked very hard to separate sense from nonsense. So when they say they're not going to do traditional offsets, they're not. In a brilliant ad campaign, they have brought on Oscar the Grouch as their chief trash officer and are focusing on using municipal solid waste and converting that to jet fuel as a way to do sustainable aviation fuel, which is, in fact, a very good pathway.
Mm-hmm. Cool. And for those who are wondering about the electric taxi that United's producing, the Archer electric air taxi is designed to fly 4 passengers, luggage, and a pilot for up to 100 miles, but is optimized for more frequent 20-mile flights with 12 minutes to charge in between, which is the perfect amount of time to load passengers and cargo.
They're basically just going to be taking people to their own terminal at United's ORD facility. So back and forth from Chicago to the airport, that's a good use for an air taxi.
Yeah. So the New York Times published a piece, falling lithium prices are making electric cars more affordable. And so the questions are like, does this matter? How significant is this? And what might be causing it? If there are any interesting forces at play. Julio, what do you think?
Well, obviously it's welcome. It's nice to see commodity prices drop, and I believe it will ultimately make the cost of electric vehicles cheaper. It will also be part of a big super cycle. It's nice to focus on critical materials like lithium or neodymium or palladium or anything else, but everything has been dropping in price. The price of oil has dropped. The price of natural gas has dropped. The price of uranium has dropped. So it's nice to see this for lithium-ion batteries and for cars, but how this plays out in the macroeconomy is anybody's guess. And a change in commodity prices is not particularly central. The real question is, can we get enough lithium in the future? And thankfully, people are taking the critical materials questions seriously, and they're developing lithium resources around the world. That's really good news.
Which is a great topic to segue from into our conversation today with Kurt Howes from KoBold Metals. As we transition to a clean energy economy, demand for metals like copper, cobalt, nickel, and lithium is projected to skyrocket. According to a 2022 report from the International Energy Agency, the total mineral demand from clean energy technologies will quadruple by 2040 under their, quote, sustainable development scenario, end quote, or will double by 2040 under their, quote, stated policies scenario, end quote. While different clean energy technologies come with different mineral needs, the largest source of demand will likely come from electric vehicles and battery storage. Our guest for today's episode, Kurt House, has been intensely focused over the past few years on the question of how we can meet this growing demand. He is the co-founder and CEO of KoBold Metals, a mining exploration company working to aggregate and process large quantities of data to determine where concentrations of these essential minerals might be located. Kurt was previously an adjunct professor at Stanford University's Energy Resources and Engineering Department and received his PhD from Harvard in Earth and Planetary Sciences, studying chemistry and physics of CO2 capture and storage. Prior to KoBold, he also co-founded the company C12, which was focused on carbon capture and sequestration. In our conversation, we'll discuss KoBold's goal of aggregating global data on Earth's geologic mineral deposits to help the mining industry find and meet the needs of the clean energy economy. And we'll discuss the role and responsibilities of an exploration company like KoBold in interacting with and protecting local communities and preventing environmental degradation. So Kurt, welcome to Climate Now. It's great to have you on the podcast. Thanks for joining us.
I am delighted to be here.
So Kurt, let's talk about KoBold, which is your current company, KoBold Metals. First, the need for metals that comes with the energy transition that we're beginning to go through. How big is this need and how underserved is the mining sector today?
The challenge is we need a lot of very specific materials that do a really, really good job at one thing, and they're really hard to replace. And those metals are underproduced now. KoBold is working to accelerate discovery and development of what we call the materials of the future. This is 4 commodities. It's lithium, cobalt, nickel, and copper. Those 4 are the sort of big 4 that are essential for broad electrification. The more we have of all of those, or the cheaper all of those are, the better. By 2050, we need to mine an incremental $15 trillion worth of new material. That's not including active mines that are producing. So 15 trillion from new mines of those 4 materials, and to electrify the transportation fleet. But before those mines can be built, they have to be found, right? And in rough numbers, that corresponds to about 1,000 new mines. Wow. So new deposits discovered and then built into mines. The industry as a whole would take about 500 years at its current pace of discovery and development to pull that off. Something that's really interesting is that the industry has actually been getting less effective at exploration over the last generation, last 30 years. So we've coined this term called Eroom's Law of Mining. Eroom's Law. Does that make sense to you? Eroom? What is Eroom backwards?
Moore's Law.
Moore's Law. It's Moore's Law backwards, right?
Moore's Law backwards.
Yeah, because the industry has on a metric that we've defined as exploration effectiveness, which is number of tier 1 or tier 2 discoveries made per dollar of exploration expenditure. Exploration effectiveness has dropped by about a factor of 10, a factor of 8 in the last 30 years. If you spend 8 times as much money, you find the same amount of stuff as you did 30 years ago.
Right.
So why is that? The first reason is that the easy stuff has mostly been found. It's an unfortunate accident of timing that the industry has basically fully depleted their inventory of easy to find things right at the time when we need to actually massively accelerate discovery of these 4 key materials. And so what we're trying to do to address it is massively improve the success rate. Bend Eroom's Law up. And we're doing that by, to oversimplify a lot, massively better use of data, basically turning exploration into a science by systematic use of data.
I like the Eroom's Law. I will remember that. That's a good one. So can we talk a little bit about the platforms that you guys have developed, TerraShed, SM, and Machine Prospector?
For sure.
Okay.
So our tech broadly lives in 2 categories. TerraShed is the data system, and Machine Prospector are the suite of algorithms that interrogate that data. So this is fun, really. Humans have been collecting information about the physics and chemistry of the Earth's crust for centuries. Almost all of that data is in the public domain, well over 95%. But it's horrendously distributed and organized. Think old, musty geologic libraries, academic papers that are out of print, old company filings, permit applications, all kinds of stuff like that. That's where the data is. It's like the messy data of messy data problems, right? We have a very large investment in identifying all of those sources of data, aggregating them, and this can be anything from from brand new Worldview 3, high spatial resolution, high band resolution satellite spectral imagery, or it could be 100-year-old drilling report, right? Handwritten report.
What does that mean, though? So do you have literally people going around opening filing cabinets and trying to find all this stuff, or what does that actually look like?
Yeah, we do. I mean, we have a lot of people spending a lot of time online and contacting repositories and doing things like that. There is a lot of information digitized, and there's still a lot of information digitized that we haven't even gotten access to yet. Once digitized, that's only the very beginning. We have a lot of work to do to ingest it and to transform it into what we call our universal data schema, which means all the same types of data are organized in the same exact ways, and therefore algorithms can systematically work through all of them. And if you think about that for a moment, like until you have that, you cannot search the Earth's crust systematically. And since nobody has that, then we know nobody has searched the Earth's crust systematically.
Right.
And then, but to your question, we have digitization efforts. We have a really exciting one in Zambia right now. The Zambian State Archives have over 100 years of exploration and mining data in paper format in multiple warehouses. There's actually several, I'm pretty proud of this, several different international government bodies like WTO, et cetera, have at times written reports about how what they should do is they should get a bunch of money together and get a bunch of sponsors and all the stuff so they can digitize that resource. Well, we just went in and did it. We just went to the state archives in Zambia and said, we'd love to digitize this, and we're going to give you all the digital files. And they said, great. And we're doing it entirely at our expense. And we're just doing it. We're doing that in many other places around the world.
Cool.
So that's TerraShed. And then Machine Prospector is at this point, I forget, it's something like 400 different modules which do all manner of things to interrogate that data and to make predictions about where in the Earth's crust we're most likely to find compositional anomalies, right? That's what we're looking for, right? So like, think about it, say you're looking for nickel, right? The background concentration of nickel in the Earth's crust is about 70 parts per million. A nickel ore body, an economic deposit, is like 20,000 parts per million. So we want to find these very, incredibly anomalous events where nature has concentrated that background up by a factor of 300-400. Looking for these extreme values, right? These extreme outliers. That is what the sort of data science challenge is. And it's a really cool and really hard problem.
Very neat. So I want to ask you the big question about mining in general, which is ecological responsibility and how you guys think about that. Copper mining makes up the largest percentage of metal mining and processing waste generated in the United States and some of the largest Superfund sites. So how is KoBold thinking about sort of implementing responsible development of mineral deposits? How does that?
Super good
thinking about that.
Yeah. So let me start with the sort of broad challenge, just to put it into context. So all the materials required to electrify transportation, say, all that material is actually less than the material than the mass of coal that you would move around over the next period of time if we didn't decarbonize, right? So there'll actually be less mining in sort of comparison. And then once all that mining has taken place, you don't have to mine anymore, right? Or at least because the renewable energy economy can give rise to the circular economy. Because unlike coal, you burn it, it turns into CO2, it goes into the atmosphere, you never get it back. It's done. It's a one-way trip. Copper, nickel, lithium, those things will go into cars, and they get recycled again and again and again and again. And in principle, you can recycle to 100%. Economically, it'll probably be, depends on prices, but certainly over 90% for the valuable materials. One car's worth of batteries will support 100 years worth of driving. That's just to put in the broad context. Kind of to your direct question, what does it mean to be a responsible miner, right? Or it's responsible developer? What does that mean? What does that look like? How does that compare to unresponsible activities? And there's a ton of things in there. One thing immediately is your local impact, right? So undoubtedly mining these key materials is good for the world because we get the world off of fossil fuels and we stop frying the planet. But that's not necessarily true for the communities close to the mine. They can suffer a disproportionate impact from various local activities. And so you have to take that extremely seriously. That's everything from damage on roads because truck traffic goes way, way up, to local pollution from smelters, to what it does to the sort of natural landscape and how people feel about the scars on the landscape. All of those things are really important. Mm-hmm. To first order, we'll never operate in a place where we're not wanted, is probably the best way to say it. We will only operate in places where the local communities welcome us because they want the economic development, they want the job opportunities, they think it's a net positive. And all the places we're currently operating, that is the case. There are places we have decided not to operate because we thought that wouldn't necessarily be the case.
What do you think the role of companies like KoBold, so prospecting companies, is in eliminating or reducing environmental degradation? You've talked about community benefit, but then there are other resources which are, yes, they're local to the community, but they're arguably like larger resources than just the community's resources, like maybe clean water or air or those kinds of things that, yes, they're sort of local in origin, but they're not necessarily local in terms of value.
Yep, fully agree. Fully agree. Take a huge responsibility. To separate exploration from mining for a minute, impacts of exploration are actually really, really small. We do engage with communities from the very beginning for all kinds of reasons. And even when you're just exploring, the actual impact, it's basically nothing. Mining is a whole different story. You go and develop a mine, it has very real ongoing impacts and maybe long-term impacts. Things like water quality, those are like non-negotiable. I mean, that's your license to operate. Fundamentally, it's a matter of making the investments to protect the water table. If you don't do that, you might save a little money and you will forfeit your license to operate, both legally and morally. That's sort of not negotiable. Same with air quality. And any place we operate basically with American standards. If locations we're operating have lower standards than the EPA would apply to an American jurisdiction, we just go with the American. We go with whatever's higher, basically. Mm-hmm. It is a moral imperative. It's also a business imperative. It's good business to protect those things, because we need 1,000 mines, right, to fully transition the economy. We need to build these things again and again and again, right? But the only prayer KoBold has at doing this many, many times is by maintaining a reputation as being the best operator.
Right. That's fascinating. Well, Kurt, you seem to really be attracted to really easy businesses. Just the easier, the better, right, for Kurt. No, anyway.
Yeah, exactly. Nothing worth doing is ever easy, right?
Right. That was Kurt House, co-founder of KoBold Metals, discussing the environmental impacts of the mining industry, and prior to that, how better data on mineral concentrations across the globe could help meet the needs of the energy transition. That's it for this episode of the Climate Now podcast. For more episodes, videos, to sign up for our newsletter, or register for an upcoming event, visit climatenow.com. We hope you'll join us for our next conversation. Climate Now is made possible in part by our science partners like the Livermore Lab Foundation. The Livermore Lab Foundation supports climate research and carbon cleanup initiatives at the Lawrence Livermore National Lab, which is a Department of Energy applied science and research facility. More information on the Foundation's climate work can be found at livermorelabfoundation.org.